Today's webinar, Maximizing Query Performance with Managed Statistics in Starburst Enterprise. I'm joined by two of my colleagues, Russell Christopher, Director of Product Strategy, and Dan Cataluppi, Product Manager. We've got an exciting webinar lined up. They're going to talk through some new features in Starburst Enterprise, impacts performance, especially on disparate data and data federation. Russell and Dan will talk you through what this means and do a live demonstration as well. We will be answering questions at the end and throughout. So if you want to leverage that chat panel to enter any questions that you have, we can answer them there as they come in, and we'll also address unanswered questions for the group at the end. With that, take it away, Russell and Dan.
All right. Hi, everyone. Yes, and I'm unmuted, which is a good thing. Russell Christopher, Director of Product Strategy. I've been with Starburst for about 2 years now. Began my data career way back in the old days at Microsoft forever ago. There wasn't even a cloud back then. Was then fairly early on at Tableau, did a data catalog startup, then Alteryx, and now here. I've always been a data person, love my data, and I'm joined today by Dan Cataluppi. Dan, you want to introduce yourself?
Yes, thank you. So I'm Dan Cataluppi, and I'm a product manager of Starburst Enterprise, and I've been part of the Starburst team for about 1.5 years. Prior to Starburst, I've worked with a variety of products and within data in the healthcare industry, the cybersecurity industry, and the data analytics industries. So yeah, I'm happy to be here and ready to jump in.
All right, so let's go to the next slide. And I think everyone who is here, probably if you're interested in statistics and managed statistics, you know it's a reasonably esoteric thing to talk about. And so the architecture diagram that you're seeing, I suspect you've already seen before, and you probably could present this just as well, if not better than I can. But just in case we have some new folks in the room, I'm going to kind of quickly go over this. Hopefully I can focus on why you care versus what it is, because our approach is essentially very different than a traditional data warehousing model. We flip the script essentially and allow you to access all of your data, no matter where it lives. We provide you the fastest time to insight. And our goal ultimately is not for you to build that perfectly efficient ETL pipeline. Instead, it's to allow you to access the data you need to generate the insights to drive your business as efficiently as possible. So tactically, what this means is that your data consumers are going to be able to run analytics on all of your data, and you get to keep the data where it makes the most sense for your specific and evolving needs. So that the separation of data and data sources means your data consumers can build whatever they need, while you get to build the data architecture that meets your specific business requirements, your data requirements, and most importantly, it allows you to drastically increase data access to all of the various cross-functional teams you might have in your org. So Dan, if you could go to the next slide, and you all will see right in the middle our analytics engine. It's really the center of our universe, and it optimizes and breaks up an analytics workload, sending it directly to the appropriate data sources. And that gives you fast time to insight, again, without having to do all of the pipelining stuff. Around that engine, we built a set of enterprise grade features. Like literally, that's what managed statistics is. It's one of those things to help us manage and optimize performance, costs, security, et cetera, as well as just make it easy to deploy and consume. So in addition, we've built and tested a ton of off-the-shelf connectors to the most popular data sources and clients that are out there, so your users can get up and speed just as quickly as possible. So when all is said and done, what this means is you have full control and the ability to optimize the tools that you use, the data types you're going to generate, what, files and table formats you want to store data in, and ultimately how you extract value from that data. So hopefully that made sense. I'm going to hand it off to Dan now to actually dive into the initiative. Dan?
Yeah, thanks, Russell. So as you can infer, performance is an important metric for us. It's important for us to ensure that we're on top of it. And that's why we're excited to announce Managed Statistics as a new public preview feature offered in Starburst Enterprise. Managed Stats provides another input to an already powerful query engine. It's a feature that you can enable within Starburst Enterprise to collect, store, and utilize as a supplemental table statistics feature set, leading to optimal query execution plans and performance at runtime. So through our analysis to better serve our customers, we identified that a gap existed between what some of our connectors and sources offered and what our engine could achieve with a full suite of statistics. This feature intends to bridge that gap with the supplemental support across those data sources that expose limited to no stats to help you achieve the performance that you expect and deserve. In order to understand how Managed Stats works, we need to first review the basics of query optimization. So query optimization is the core component of a database or analytics engine that evaluates all possible query execution plans for each query that's run. With a set of inputs, Starburst's Query Optimizer scans for the optimal plan that it believes will result in the most performant and cost-effective execution, optimizing for whether it's CPU usage, I/O, memory, and/or network usage. You can think of it as the quarterback of the platform, taking in the various inputs and making a decision on which player may be best to pass to in order to maximize yardage for that play. So our Query Optimizer works hard to determine the ordering and distribution of query operations across the worker nodes to maximize efficiency. So in the world of analytic engines, there are really two key maturity stages of query optimization. The first being rules-based approach. This approach evaluates against predefined rules to logically identify the best query execution through matching criteria. This first stage evaluates all queries and tables without any knowledge or statistics about the underlying data contained within the tables. And this leads to a logical assertion of which operations should be performed first, second, and third in the query plan. This approach works well, but it's not always optimal. So that leads us to the next stage of query optimization maturity, which is to enhance upon the rules-based approach to make smarter decisions. So this cost-based optimization approach allows our engine to take table and column statistical inputs to make those smarter decisions, opening up a world of possibilities when evaluating and choosing an optimal execution plan for that query and tables in question. So with detailed statistics, we can evaluate costs, resources, and join or just generally node ordering depending on the size and distribution of the data. So in summary, managed statistics are another input to the optimizer to help it make better decisions. Now, we've discussed the benefits of having statistics for our cost-based optimizer, but you might be wondering, what if there are no statistics? Well, without statistics, our engine has fewer inputs to make query optimization decisions. Our engine will still work to choose the best execution plan with the available information. And it's also important to note that optimizations, not all of them use statistics, so not all is lost. But without statistics, it's increasingly important that users pay close attention to the structuring and ordering of their query to manually realize the best performance possible. So there's a little bit more responsibility on the user. So that's why stats are a key input to generating an optimal query plan, because who doesn't want performance boosts if they're available? If we can do that, we don't really want our engine processing information like White Goodman and Dodgeball. So in real-world production environments, users are running all sorts of complex queries across various connectors. Many sources really do expose statistics for our consumption today, which is great. However, there are some popular sources that expose only limited data points or none at all. As a result, you might see slower queries or, upon investigation, strange query plan ordering that you didn't expect, and even just greater consumption of the cluster resources than you had hoped. Well, these issues can be a result of lack of proper statistics, so it's worth investigating. For example, a source could offer only statistics for the percentage of nulls, but could be missing the distinct value counts for a column. This prevents the engine from really getting a full understanding of a particular column. Or for example, Snowflake only exposes row counts, but does not share any column statistics at all. So without that, we cannot truly understand the size of the join, preventing us from being able to properly decide the order of the join, which can result in increased costs if not done correctly. Teradata, Postgres, Oracle, and some others may not collect or share statistics on views, forcing a user to seek out better performance by querying the underlying tables directly. Well, most organizations don't typically want all users having the ability to query the underlying tables directly. Those users working only with views then could certainly have a frustrating querying experience without statistics as a result. So a last example I want to call out is that there are some connectors that don't share statistics at all. BigQuery does not expose any stats with Starburst Enterprise. And so without those, we're doing our best on limited information. So with these gaps, it's possible that the query engine could, in some rare use cases, run out of resource limits when trying to read in more data than necessary. This forces the user then to have to rerun the query after manually reorganizing it to run more efficiently. So all this translates to bottom line costs to the business. And this is what we wanted to address. So you're in luck because our support for supplemental managed statistics has grown to a large list of connectors that we offer within Starburst Enterprise. We want to ensure that you can realize that improved performance through optimal node reordering when running complex queries. We want you to be able to push down more parts of the query and ingest fewer data points into the local cluster. We want to be able to give you a complete view of your Snowflake table so that you and the engine can make more informed decisions. And that's inclusive of views too. So as we previously mentioned, we know that Teradata, Postgres, and others cannot retrieve stats at all on views. So being able to see improved query performance when interacting with views, and then say, pushing down a query containing views, a join query containing views, that can just make all the difference in a user's experience. So what we collect, when you peel the onion back a little bit, you'll see that when running the collection operation for managed statistics, we collect and store a full suite of table statistics, including the row count of the table and various stats for each column. That includes retrieving the fraction of nulls in a column to understand the data completeness of that column, capturing distinct value counts to understand the array of distinct values within a certain column, the min and the max values if the column is numerical in nature, or the total size of textual data if applicable. And these all contribute to our engine being able to make those smart decisions on optimizing your query plans. So with that covered, I will give the mic back to Russell to cover some high-level examples and share a demo.
We're going to start off here with a fairly abstracted example. It's so simple, it almost kind of gets into the land of make-believe, but it's a good story, and stories and the happy endings kind of help you learn life lessons. So we'll stick with a simple example here. In our fable, we have the orders table, right? There are lots of rows in the orders table. We're joining that table to our line items associated with orders. We have tons and tons and tons of line items. And then finally, we have the part table. It typically is going to have very high cardinality. Each part, has a unique key of some sort, and we're associating that to the line item. So if we're in the land of white good men with maybe not so great information about what this data looks like, there's a fairly high probability we may just go with whatever the user writes in terms of join ordering, et cetera, et cetera. So in this case, we very well will take our orders table, join it up against the line item, get a pretty beefy result set when all is said and done, and then limit that result set by joining in our part table. And again, we're going to get an answer. It just may not be super efficient. So if we go to the next slide, what we want to do is take advantage of statistics. And we'll dive a little bit deeper into how you actually collect statistics in a bit. But let's assume that we have done that. We might issue the exact same query that we did in the previous example, but different things are likely to happen in terms of plan optimization. And so an example of what that might be based on the row counts that we're getting from part and line item and orders, we might actually choose to join line item with part to begin with, get back a much smaller result set, and then further limit it with a join to orders. That's one possibility. Another possibility might be we actually take that query as is and just push it down to the data system. Or maybe that query is slightly modified and then pushed down. But the moral of the story is, before we're getting a result with okay or maybe not that hot performance, and here we have more choices, more options in terms of making a good selection. So let's go to the next slide. How do we actually use this? And in this scenario, we're going to be creating statistics on top of a Teradata view. So I'm doing an alter table against a view called TDView, and I'm executing a brand new function, which is called collect statistics. Pretty clear on what that sucker does. I can actually see what those statistics look like with show statistics. And when and if it becomes time to clean up, I can delete the stats that I've generated with the drop statistics function. Now, the final thing on this slide is actually pretty important. It's an example of actually generating stats on only certain columns in a table or view. When you have a table that's really wide or really deep, creating stats isn't something that is free. There is a cost computationally to do this work. So in this case, we're passing in an array of columns. My array happens to only have one column name, it's region key, and we're going to do a lot less work when all is said and done. So that's something to keep in mind. We'll talk about this over and over again throughout the presentation. Let's go to the next slide and we'll get into how you actually configure this. So this is the clusters configuration file. Most of the properties that you see here, and of course, we're not showing you every single one you deal with on a daily basis, but there are a couple of new ones. The first is the most important, and that's manage-statistics.enabled. Yes, we're going to set that to true, and now the feature is actually turned on. The second one is actually a little bit more interesting and actually sort of future facing. And I need to give you a little bit of background so you understand what that means. When we generate statistics against whatever we're touching, we actually store those statistics in the database that you all probably know as the query logger database. That's where we do things like store query history, where we store policies and ACLs for security, where we do event auditing, etc. It doesn't make a whole lot of sense if users are issuing query after query after query for us to have to round trip to that query logger database each time. It's pretty chatty. So our engineering staff actually built an in-memory statistics cache that's always up and running. And that's what we really want to query when all is said and done to pull statistics. So in short, this particular key value pair allows you to set how often we're going to check back with the materialized version of the statistics sitting in the query logger database. And the reason, by the way, I said this is sort of future looking is this is not really useful to tweak unless you have additional capabilities like the ability to maybe refresh statistics automatically, which we haven't gotten to yet. Dan will talk to that in a few minutes. So for now, we bake this capability in here knowing that we're going to use it later, but you on a day-to-day basis are probably not going to touch it that often. Still just wanted to let you know that it's there. So that was pretty long-winded. Let's go to the next slide and we'll get into what you need to do for each of your data sources. So for each catalog, there are two additional properties you're going to turn on. one of which you're probably already familiar with. This is something that you set not only for your coordinator, but for your workers and other services. It's an internal shared secret that allows all of the nodes to sort of have conversations. So you're going to set that. That's kind of a new thing to do inside a catalog properties file. Again, you're also just going to turn on the managed statistics capability on a catalog by catalog basis. So pretty straightforward when all is said and done. Okay, let's go to the next slide. And we have a demo coming up. We're going to tell you a little bit more about the data. This is actually one of my favorite data sources. This is a archive.org data set. And they actually update this either daily or weekly. I've forgotten, but it's essentially every single post, every single vote, every single user out on Stack Exchange for all of the various subs that are out there. So I love this thing. And I grabbed two of them. I grabbed the biggest one, which happens to be Stack Overflow, and also a smaller one, a super user. I dropped these on Postgres. I created statistics on all the tables. I index things the way you're supposed to. So these things are reasonably performant on their own. And I use these as my crash test dummies. What we're going to do in the demo, Dan, if you could go to the next slide, is we're going to take a look at a couple things. First of all, the query that we'll be executing is a pretty well-known query, actually, where if you're not limiting it by a username, this will literally return the sort of most upvoted posts and answers to questions by tag. So if I'm in the super user sub and I'm answering, I don't know, like lots of questions about Windows 95 or something, I might see my username and the fact that I have a bajillion upvotes on all of my answers. I'm limiting this to one person's name just so we get results back reasonably quickly. And the other thing to call out is that we're leveraging views here, not the tables. You see V votes, V tags, V posts, etc. Again, Dan's mentioned this a few times. Postgres does not have the capability to create stats on top of views. So this is a great way to sort of see a before and after in terms of how all of this works. The other thing that I'm doing is I'm doing the kind of kludgy, clunky join technique of doing a cross join and then limiting it in my where clause. I'm not doing the handsome inner join on whatever type language that we've all been taught to do. I actually did this on purpose just to see if I could confuse the query optimizer by doing this, or if I would see different results. I frankly didn't. I got the same query plans no matter what I did, but I tried. So little credit there. So let's go to the next slide. The tests that we're actually going to do will begin by executing the query that you saw against views without statistics. And we are typically, can't even say the word, going to see that those come back more slowly. We're going to generate stats at that point. We're going to re-execute the query. We will see a faster response time if the demo gods are with me. And then we'll actually go a little bit off track. And I want to give you another arrow in your performance quiver. We'll take a look at a pass-through query, which is another way of potentially improving performance. It has nothing to do with managed stats, but ultimately the goal here is to get results back quickly. So this may be something that you all are interested in. The query editor, and we'll dive in. The very first thing that I'm going to do is actually make sure that I prepared the demo correctly by looking for stats on all of the views that we're going to be querying. And sometimes I forget to do this, so I double check myself. Okay, we're good. Here are all of the columns in the various views that I'm looking at, and I can see that I have null values across the board for all of these. So happiness. Now we're actually going to execute that query that we were looking at before. Again, these are using the views without statistics, and typically these come back in about 2 to 3 seconds, about 2 seconds on that one. Next, we're actually going to make the magic happen. We will create statistics on all of our views. Now, I'm doing it 2 ways here. Notice on a lot of these, I'm just creating statistics on all of the columns, but on a few of them, I'm passing in the array. So I'm only creating stats on maybe 3 of the 15 or 20 columns, or for the V users table, I'm only passing in 2 columns. columns to create statistics on. I can show stats again, just to kind of see what the results look like in these underlying tables. And you can see again, like for the first, I have all of my columns and I have the stats that we've been creating. Or maybe again on posts, which is a pretty deep table, or wide, I should say. Here, I only have stats on the 3 columns that I specified. So it looks like we're ready to go here. We've done all of the pre-work. Now we'll go ahead and execute that view again, and we're going to get results back, in this case, in 0.54 seconds. So like, that's not a bad difference in terms of query response. What I want to do is show you what happened under the covers for these two, and then we'll circle back and actually play around with the pass-through query. So we'll get into the query overview, do a quick refresh here, and here is the quick executing version of our query. I'm just going to kind of open that up and we'll look at it in a second. And then I got to scroll down here and find where I was creating all of the statistics. And right before I begin on that, I will find right here the one that ran more slowly. In this case, it was 2.53 seconds. So we'll crack this one open and we'll begin by investigating it. We'll start off in the advanced area. And right away, I can see something that's pretty interesting. We literally addressed each and every table, or in this case, view, in that query and pulled rows back. So I can see that we were likely doing all of the joins locally. So we actually pulled, and this isn't a lot of data, but no data is better than 5.2 million rows. We pulled back this amount of data to the cluster. We leveraged about 90 megs of RAM at peak as we were doing all of the joins. We took almost 4 seconds of CPU time. And if we want to take a look actually at the query plan itself, I'm not going to dive really deep into this, but just even visually, you can kind of see that we were doing operation after operation, which essentially was go get the data, join it to the next thing. Now go get more data, join it again. Get more data, join it again. So it's very iterative. Now, if we contrast and compare that to what was going on with our fast query, the very first thing that jumps out here is we actually generated a single query and executed it. We essentially just threw this over the fence at Postgres. So instead of bringing, 5 million rows back, we only brought back about 80,000. Instead of using 80 something megs of RAM, we used like a couple hundred max. Next to no CPU time. Of course, this is because Postgres was doing all of the heavy lifting. And of course, you know, the icing on the cake is the fact that this came back in just slightly over half a second. So again, if we kind of look at the query plan as well, we're going to see it's much more simple. We're doing a lot less work locally anyway when all is said and done. So that's, you know, at the highest of high levels, that's it. We had more options. We handled that situation more intelligently. What I'm going to show you now is actually 2 things. I was going to jump right into the SQL pass-through query, but I probably should show you how to clean up as well. So we're going to clean up here by executing drop statistics. Now I'm getting rid of all of those local statistics. And as one would suspect, if I go back to the query, re-execute the query, well, now it's slow again. It's 2-ish seconds, 3-ish seconds, whatever it may happen to be. We're kind of back to that White Goodman behavior. All right, so finally, let's take a look at pass-through query. This is a slightly different animal, first of all, because we are directly addressing the base tables. We're not using the views anymore. We're going right to the tables, which Postgres has statistics for. So literally, this is about as good as it can get. Whatever our limits and capabilities are as expressed by Postgres is what we're going to see here. So we'll go ahead and execute this. This came back in 0.44 seconds, so marginally faster than what we saw going through the views that had local statistics on top of them here in Starburst land, but not a huge difference. So that's it. We're going to go back to the deck. just want to kind of reiterate what you actually saw. The super user example was very straightforward. We went from 2 to 3 seconds to about a half a second, and the direct pass-through was just about the same. For the larger experiment, which, I was going to sit you down and make you watch a query spinner go for 1 minute and 40 seconds, it took about 1 minute 40 with no stats, took about a minute with stats, and actually was faster than direct pass-through, which sort of surprised me. And I frankly didn't investigate that too much, but this kind of just demonstrates the fact that your mileage may vary and you should spend a little bit of time experimenting. So this is great news, right? We have a good way to improve our performance, but of course, nothing that is good comes free, right? There's always a cost involved, and now we're going to talk a little bit about that. So in some cases, when you're generating statistics, it's pretty straightforward. And these are, by the way, the actual SQL expressions that we fire at the columns or table to get our stats back. So if I'm figuring out a range, I'm doing a min and a max, right? No big whoop. It's a pretty straightforward aggregation. However, if I'm counting distinct values, that's a count distinct, right? That is a non-trivial thing to do. That is kind of costly from a performance point of view. So just wanted to point all of this out so you're aware of what is happening under the covers. Speaking of what happens under the covers, here is literally the query that got executed against Postgres when I was generating stats for the users table coming out of the Stack Overflow, or Stack Exchange data. There are 3 things going on in this query. First, we grab the row count for the table. That's the SQL in blue. Then we're generating stats for a column called ID. That's the purple text. And we're doing a couple different things there. We figure out the range. So that's the min and the max that you see in the sub select at the very bottom. We're figuring out percentage of nulls in that column. And then we're also figuring out what is the distinct count of IDs. And again, that's sort of the expensive operation. In white, we're pretty much doing the same thing, but for a different column. In this case, it happens to be display name, which is a text-based column. So we're still figuring out, how many of these values are out there. And we're figuring out what is the percentage of nulls. But then rather than figuring out a range, we're actually going in and figuring out the size of the text. So this is not, a lightweight query, which is a perfect segue into like what to do and what not to do. One of the things you don't want to do is just generate statistics willy-nilly every hour or every day just because you can. Right? You'll want to wait until the flavor or the taste of your data you think has changed significantly. That's when it's time to regenerate statistics. You want to use the in-memory stats cache. That's actually on by default, so you'd have to go out of your way to turn it off. There's no reason why you'd want to turn it off, because then again, you're making all of these unnecessary round trips to the query logger database. This is, I think, now the 5th time we've said this, but if you have big tables, wide, deep, focus on just gathering stats for the columns where there will be benefit. And then finally, don't forget you have the goodness that is full query pass-through. That's brought to you by a relatively new capability that we built about a year ago called polymorphic table functions. Again, when you issue one of these queries, whatever is local on that data platform, you take advantage of. The syntax is fairly straightforward. You do a select star from system.query, and then the sub query that you see inside the parens, that's actually your query. Okay, so at this point, we've talked about what is now. Dan is going to take a little bit of time to talk about what is next. So on to the next slide, and Dan, take it away.
Yeah, thanks, Russell. So at the beginning of the presentation today, I announced that Managed Statistics is in public preview. So looking forward, there are a couple things that we are interested in potentially pursuing. The first of which is obvious. We want to continue growing our list of connectors that support Managed Statistics, especially those that have limited or no stats at all. So that's the utmost importance to us. Second, we want to explore making and running Managed Statistics a little bit cheaper. So whether that's through random sampling, we can sample a portion of the table and extrapolate that. So sacrificing a little bit of accuracy to benefit on the cost. And we shouldn't see too much performance difference as a result. Secondly, we also want to introduce the option to utilize a prox distinct instead of count distinct. As Russell had mentioned, count distinct can be pretty costly if it's especially a large table. We want to utilize prox distinct that is within a certain standard deviation, and we could use that as a metric. Next, I think we mentioned it before, is also scheduling statistics. That's something that might be of value to many users, so that users don't have to worry about their statistics going stale and skewing their results and not results, excuse me, skewing the query plans to perform less optimally. So having fresh statistics can be important, and this is where the caching can become even more beneficial. And not only that, managed statistics aside, we want to continue improving our engine. We can throw as much inputs as we want, but we want to be optimizing what the engine does with those inputs so that we can drive better performance overall. So that's generally some of the opportunities that we have ahead of us. So walking away from this presentation, we want you to really understand that managed statistics is a supplemental feature that can really impact your query planning, resource utilization, and improve performance of your queries. Really, it comes down to, importantly, that if you have joins included in your queries, we really suggest that you look and explore utilizing managed statistics where applicable. But do keep in mind that if run every day for the whole table on large tables, you can generate some costs using this. So it's a fine balance of using what you need and getting by with what you have. So with that said, we wanted to open it up for any questions that might come through the chat or any questions that Dan has been receiving offline.
Obviously, for Dan and Russell, the questions that are on the slide. Is there anything you want to call out here? I can see, as great as managed statistics is, people thinking that it might be their silver bullet to solve all performance problems and be everything for a query. Is there anything you guys want to touch on with any of these questions? There were some that came in offline that I'll also follow up with.
Yeah, I can cover the first one, and then Dan, maybe you can talk about BigQuery, for example. I think common sense applies here, right? If there was a silver bullet, we'd all be done, and we'd drink our Mai Tais on the beach. So managed statistics will absolutely move the ball for you in terms of improving performance, I should say. But it's not a one-stop shop that will solve for everything. So use it and experiment with it. It's a good fit, but it won't always be a good fit.
And I do want
to add about BigQuery.
Yeah, and before I move on to BigQuery, I do want to add that it's within the context of all the features that we have available, right? So Russell called out that if statistics isn't working out, you should test out with polymorphic table functions. While it might be a use case by use case basis, but also managed statistics is more accessible because polymorphic table functions is a pretty strong feature that you might not want to give certain users. So enabling managed statistics can help you move the ball forward for your users holistically. With respect to BigQuery, we don't have that support quite yet, but that's something that we are looking for. We know that there's increasing consumption of usage of our BigQuery connector, and that's one we know that doesn't provide statistics. So that's on our list. And if there's others that you are working with or are interested in, please reach out with any suggestions.
Yeah, the next one about, can we do managed stats on top of Hive, or maybe my table formats or Iceberg or Delta, whatever the case may be. Can I use this stuff against those? The answer is no, because typically, at least right now, the analyze command that has already been created to create statistics on top of those data sources is optimized for that sort of scale. If we get lots of people saying, hey, but I'd really like to use this stuff too, because for whatever reason, our keepers of the lake or lake house refuse to create stats, and we want to, create some small slices of stats, that's something that we might consider. But right now, you just want to use the tools that have already been built to solve for that.
Yeah. And lastly, there's another question here that we can get often, if it's enabled in Galaxy. Right now, it's not, no, but we are constantly working across products to ensure that we are offering a similar user experience and feature sets.
Any other questions come in chat, or the offline questions?
There was a couple offline, if you guys don't mind. One was around not only checking and ensuring the accuracy and of statistics. Is that possible? And then also, are there any privacy or security considerations when people are collecting and storing managed statistics, especially for sensitive or regulated data?
So the checking or managing of statistics, I think maybe that question in a roundabout way is saying, like, how can we make sure that they're right? And if I'm interpreting that right, I would say you're issuing SQL, right? So when you fire that query at that point in time, we're doing a sum of a value and dividing it by something else. It's going to be correct. Now, is it still correct a month from now or 2 months from now? Maybe not. And that's where you might want to consider deleting the statistics and regenerating it. Of course, another thing that you can do based on your expertise with the various data systems that you're integrating with is literally go to Postgres and, for example, do a select star from PG_stats and see the actual values that Postgres has generated against its own stuff, and then compare it to what you have. Dan actually mentioned something, on the roadmap that's kind of interesting, in that one of the things that we want to do is estimation when we are creating our statistics. When I was playing around with this stuff, I actually found, and I didn't want to make it about that, so I didn't include any slides on this, but I actually found I could create statistics against the Postgres tables myself. And because I was not using sort of a lighter weight estimation to generate the stats, I paid a higher cost to generate them. But when I issued queries directly against the tables from inside Starburst, I was actually getting an answer back faster than when I was using the statistics that were generated and stored on Postgres. So again, it's kind of one of those things where you'll want to experiment and kind of see what's best for you.
Yeah,
it's great. Was anything to add, Dan?
Yeah, I think you had a second question about security and privacy. So while anyone can run these statistics, it's going to be bound by the privileges set. So if I have any column masking or row filtering column masking, really, I shouldn't be able to see the statistics for that column. So it's within the context of your privileges. Also, keep in mind that you can generate statistics only for the catalogs, only for the columns that you need. So there's ways to avoid those privacy concerns through those methods.
Yeah, that's a great point, and that may get back to the accuracy of the stats, right? If I'm creating statistics on a column that's masked, and essentially the data that comes back is 5 asterisks, then is that metric actually valuable from a query optimization point of view? No, it's wrong, actually. So it's actually a great point from Dan. You probably want someone who has access to the actual values to run the create stats process.
Awesome. There was one more question that I think we got time for, and it was, and I know you touched on this a little bit, but maybe anything further on managed statistics being used in conjunction with query caching mechanisms to even further optimize query performance.
Yeah, Dan, you want to talk about that maybe in regards to warp speed, or I'm happy to also.
Yeah, so right now we have limited testing with other features like warp speed. So we're in public preview. We want to be able to really roll it out with all those types of explore those compatibilities with other features. But right now we wanted to focus on the primary use cases. But yes, we do encourage adoption of and testing with other instances and other features that we have to really push the limits of this feature that we have here.
And realistically, if I wanted to use like the lake focused autonomous indexing and caching capabilities of warp speed to accelerate portions of a query, I absolutely can do that, especially if I'm doing federated querying. Another thing, it's a little bit of a cheat, and I mean that in a good way, is using our capability called table scan redirection, which essentially allows you to copy portions of a table from wherever they are and store them on the lake. We can accelerate that as well. So layering these features on top of each other or using them for sort of best suited purpose absolutely works and typically is a win.
It's great, exciting stuff. Thank you, Russell and Dan, for your time today, and everyone for attending.